The broadcast is now starting. All attendees are in listen-only mode.
Welcome, everyone. I'm Tracy Fitzpatrick, and I'll be your moderator today. Thank you so much for joining us here at Netcom Learning, a market leader in promoting lifelong learning, training, and talent development solutions. And we're very excited to host today's event, Masterclass, Getting Started with AWS DevOps. And presenting today's topic is Brian Wu. Brian has 22 years of consulting experience in information technology industry. With his rich training experience within IT, covering a wide range of skills and knowledge from data center and network infrastructure to more recently cloud architecture and implementation. He's been training up the enterprises in all industry level verticals to help their adoption to cloud technology. Now, please bear in mind that this is an overview of a very robust topic. We do offer a collection of technical and business courses that can be tailored toward your specific requirements. If you are interested in a further discussion, you can make an appointment with our learning consultants through our website at netcomlearning.com. Today's session is also being recorded, so you'll get free access to the recording in the next 24 hours via email. Netcom Learning helps customers build innovative learning organizations by achieving a smarter workforce, adopting to change, and driving growth. We do this with a broad catalog of offerings, developing customized learning plans, and our global delivery capabilities. Since 1998, we've been empowering organizations with our managed learning services to help them reach optimal performance results and address challenges. We do have 9 practice areas in which we specialize. They encompass people, process, and technology training. Today's presentation will be from the cloud practice area. And Netcom Learning also offers a comprehensive training portfolio for cloud courses, which you can check up there on your screens. Private training to the teams is also available, of which the learning plan can be customized to the specific needs of the audience. You can also access a variety of cloud marketing assets, such as the free 1-hour trainings, free on-demand trainings, and blogs by clicking on the available webinar handout. These offerings can be found with a simple search on our website at netcomlearning.com. So why should you attend this event today? Well, in the event, you will learn the basic practices to help your team master the most common DevOps patterns, practices, and tools required to develop, deploy, and maintain applications and services at high velocity on AWS. And now I'd like to give you a quick overview of the logistics before we get started. To begin with, you do have the option to adjust the window size to your liking. Simply hit the escape key and find the Zoom button on the top left corner of your GoToWebinar viewer. Everyone has been muted except for our presenters. Feel free to submit any questions you have for the presenters here in the questions pane, and we will address them at the end of the session. We also realize that many of you may have to leave early and wanted to let you know that as you do leave the session today, you'll be presented with a short survey. We'd like you to take a quick moment to participate in that survey because your feedback really helps us understand your learning experience and improve our future sessions. The survey answers are measured on a scale of 1 to 5, 5 representing outstanding and 1 representing poor. And now finally, I'd like to pass this over to Brian, who will be presenting today's topic. Okay,
Thank
go
you,
ahead,
Tracy.
Brian. You are live.
All right, thank you. So today's topic is about DevOps, getting started with AWS DevOps. So let's take a look on the agenda first. And for this 2-hour section, we would firstly introduce what is DevOps on the cloud, AWS. And then we will take a look on the DevOps culture, the practice, the techniques, and the tools. And then after that, we will take a look. One of the practice is related to automation by using infrastructure as code. Actually, that's CloudFormation. What is CloudFormation template? What are the components inside CloudFormation template? And how can it help us on the DevOps? And then in the middle of the section, around 11 o'clock, we will have a short break, around 5 minutes. All right. So let's get started. What is DevOps? I have been teaching DevOps class for many years, many class. If you ask 10 different people, they may have different understanding, different meaning related to DevOps. So here we take a look on how Amazon, how AWS, they're thinking what is DevOps. And then the DevOps here is basically a combination together with cultural philosophy, all right, the mindset, the people, and then a lot of practice, the practice, or in other words, we will say process. What process we could use in order to achieve DevOps? And then the tools. We will often say the tools is least important. You can use third-party tools. You can use 100% all the tools from AWS, or you can mix and match. In my demo, I will do some demo. Of course, I will use all the AWS tools, but it's your choice. So by combining those culture, practice, and tools, and then to release software development, new application features to your user, could be internal user, could also be public, public user. All right. So in that case, how can we deliver these new features, in a very high velocity rate? All right. Think about nowadays in your mobile application, you may have an update every a few days, a few updates in a week, or even in a day. You can have multiple updates. If you see any bugs, and then the vendor likely fix it immediately, or as soon as possible. So if you take a look on DevOps, there is life cycle. So first of all, we plan what new features we want to push to our user, our customer. And then after that, the developer, okay, develop using the code. Likely nowadays, very famous Java, Ruby, Python, .NET, and a lot more. And then after they develop using the code, and then they build the artifact. Say for example, if you develop Java, that may be your compile code, the Java file. If you develop with Visual Studio, the .NET, then likely the DLL and compile file. And nowadays, a lot of application running in containerized application, containerized system. So maybe nowadays, a lot of people, a lot of company build container image and then run container on, say for example, Kubernetes in AWS, the EKS, and then also the ECS. After you build your artifact, build your container image, then likely we need to test. Okay, test. The most important is automate. Okay, automated testing. Hopefully, we test 100% of the code, and then we don't want to find bug in production environment. All right, and then we release. How are we going to release to our production? Suppose we already have version 1.1. How can we move to more version 1.2, 1.3, 2.0, something like that? So, and then we deploy, and then keep going. We operate, monitor, and then maybe next week, next month, we have another new features, and then we go over again. So this is the life cycle. And the most important for DevOps is make it fast, and then hopefully automate everything. So let's learn from Amazon. If you understand Amazon, this company start from 1994. At the first few years, they actually sell books online. So this is, if you see, you just search from Google, then you can find Amazon start their business. 1994, they sell books. This is already their, original page, just like this. Okay, and learn from their experience. 20 years before, actually they release new features almost every half year, or every quarter. How can we make it faster? Okay, so nowadays I can say almost every single second they have new features. Okay, so we learn from their experience from monolithic. Okay, originally they also use a big giant server, okay, to create everything. So it means that originally they also use a lot of C++ application, and then they use a big monolithic database. At first they use Oracle, all right, and then the web server, the application server, the database all together. And then after a certain year, they found that it is really hard to scale. All right, so they break down into 2-tier, 3-tier application, more machines, and then after that they still find it's not good enough. All right, still monolithic. All right, everything all together. The application, think about Amazon. They may have the search system, they may have the shopping cart, the payment, delivery, all right, and a lot more. Okay, so very hard for them to scale. Very hard. One component goes down, affect everything. Use all the same code base. All right, so that's why every quarter they only can release the new features of every quarter or half year. All right, so from monolithic, we have a lot of challenge. We have a very large platform, long development life cycle. A lot of developer work together and then test, every component in the machine, and then very hard to scale. One failure affect the whole system. All right, and also very hard to, fix the bug, find the failure. All right, so these are the challenge, and we learn from their story actually how to move from monolithic, all right, the big giant web application server, to microservice. Of course, this is not a one-step approach. They do it by using many, many years. All right, and nowadays they have really a lot of microservice. So for those microservice, they break down into independent component. So they have a small team handle those small features. All right, say for example, some teams handle originally the shopping cart, another one handle the search system, another one handle some other component. And for those communication, the service need to talk to each other, right? So could be API call, could be messaging service. Traditionally, everything run in the same box. They talk to each other in memory, but by develop into microservice, there may be communication, between a microservice. So the network or the communication could be the issue. So the way to monitor is also different. Traditionally, we just monitor the server, and now we may want to trace, monitor, the communication. Did they success? Do we have any error, hit any limit, any bottleneck, the latence? Okay, so the trend is different. So let's come back and take a look in general. What is DevOps in Amazon and AWS point of view, and take a look on their technique and practice. So first of all, here, as we mentioned in the sentence, we have the cultural philosophy. The most important for DevOps is basically, the people, the mindset change from big giant developing team, and then after they develop, throw the problem into operation team, another big giant team. So it breaks down into a small team, small features, small component. So for having a meeting, is much easier. Think about if you have 30 developer, 100 developer, even if you want to group a meeting, it's not easy. But if we break down into small teams, we can use actually the online platform to have the meeting, and then also easier the communication channel, and it's easier to handle. So that's culture change. Okay, and then after that, we have a lot of practice, like later on we will mention the CI/CD, infrastructure as code, and then the new way to monitor. And then once again, the tools, you can use 100% tools from AWS, mix and match, or all the tools from third party. The most important is automate. So we often say this sentence here is related to people, all right? And then practice, another word, we will say process, okay? And then, here it's just tools. We will often say people over process, over tools, okay? The most important is mindset change, and then adapt the DevOps practice, and finally the tools. So if you take a look in my DevOps class, I often mention that DevOps is about remove the barriers between developer and operator. Okay, and then they just work together, so that make our developer, productive, and then also reliable. Developer focus on write the code, release new features faster, and then the operator wants stable. Okay, so they have different purpose, and this is actually what AWS or Amazon means. DevOps just developer and operator work together. In some other experience or environment, some people may have different view. They may actually set up another team for DevOps, or one Superman expert in developing and operating, and then lead all together. But in Amazon point of view, DevOps is just developer and operator join together. All right, work together. All right, so this is again the culture change. So again, people over process over tools. So think about the Amazon example. Originally, they may have big giant developing team, 100 people, 80 people. After they finish developing, all right, traditionally, and then after they develop, they throw the problem into the other side of the world. Oh, this is your problem now. You are going to monitor. You are going to operate. But what if those big giant, operation team find some bug, and then return back to developer, maybe already, weeks, months away. All right, then the developer need to take a look on the comment on the code. Oh, I did something wrong and I change. So traditionally, it takes long time, long life cycle to release the features and to fix the bug. And DevOps in Amazon point of view is just, how about nowadays we break down into microservice, and then the developer and operator, maybe just a few of them, two developer, let's say, and then two operator join together. They have their ownership, okay, to develop. You can choose different types of programming language, different version, different database. You have your own autonomous system, okay, and then own power in order to choose whatever you do to make your service good. All right, so it's just like that, okay, and then break down into very small team. So that's why they call it two-pizza team, full ownership, full accountability. The team make that features or product, and then they are also the one to support. All right, and then this is our DevOps principle, and we focus on innovation. So keep add new features to your application, your system, and then to your customer. All right, so once again, just join together. Okay, and then that's the people change. So let's take a look on some relatively technical terms. For DevOps, actually, we have DevOps practice. And people, we often mention the CI/CD. CI stands for continuous integration. It means we continuous adding new features, integrate new service, new features into our application, into our service. So, and then after that, we continuous deliver to our user, to our prospect, okay, customer. All right. So normally work together. Once again, the most important, how to make it automate and make it in a very fast place, fast velocity to do so. And then break down into microservice. And then infrastructure as code. Later part of our webinar is related to cloud formation. Okay, we can use code to create not only the application, but also our infrastructure. All right, and then monitoring, new way to monitor our microservice, and then communication. Once again, instead of very big team, a lot of communication channel. Now we just have a few people. Easier to set up meeting, to develop, and then to collaborate. All right. So let's take a look on this one. So before microservice, yeah, all developer work together. So more technical, to develop, we will likely have a develop pipeline. So from your source stage, your code, and then you build some artifact, and then you spin up the testing environment to do all the testing, including the security test, load test, performance test, UI test. And then after that, we deploy, release to our production and monitor. So traditionally, there is a big pipeline, 3 months, half year to release the new features. So after that, we eventually become microservice. But in many company, originally they have monolithic, and then instead of one step go to microservice, normally we will heard these terms service-oriented architecture. So we just break something, not really make them into small function. So it's just a kind of transition in the middle. All right. So eventually, hopefully, we can make our application, by using microservice, by developing the architecture is microservice. It's just focus on very small decouple, just break down everything. Hopefully, all right. Self-contained team to run only one thing. Okay, so if you take a look, the microservice architecture, all right, they just focus on one function, maybe just one button in your application. You may have a lot of application, a lot of buttons, right? So we focus on one thing that is really microservice. So we deploy, separately. So each microservice, they may have their own life cycle. So maybe this week we have new features on this function, and then next week, tomorrow, we will have another new features. Okay, and then each different microservice, they can use again different language, different database, and then different version of a programming language. All right, so it's very fit for using different data type. Again, traditionally monolithic. A lot of company, including Amazon, put everything in Oracle database. But think about just Amazon. We have the shopping cart, right? Do we need relational database for shopping cart? Maybe just key value database is enough. Maybe in-memory database for section data. So like that, we can have different database for different microservice. So we organize based on the business need, okay? And then everything hopefully externalize all the state, all the data. For microservice, hopefully we don't store data inside those microservice. You can actually externalize the section data into some object storage, file storage, or database. You can think about decouple the compute from your storage, compute resources from your storage. All right. So in that case, it would be easier for us to use something stateless like serverless service. All right, and then easier to automate. Okay, so this is just some concept. Take a look a bit more, and then I show you some demo. All right. So after that, the trend actually can be like this: small team, own pipeline. All right, that's the key concept. All right, for this service, this function. All right, so every different component, they can have their own, life cycle. Okay, so that's why nowadays every single second in Amazon.com they have new features to release. So if you compare, just take a look on this example. From traditional monolithic application, we put everything in the database. Just think about you go to Amazon.com nowadays to, let's say, search buy a laptop. So first of all, you go to the homepage, and then you may search. You may have search system. Suppose you can search Sony, Fujitsu, Lenovo, IBM, whatever. All right. After that, you may take a look. The statistic, which laptop sells the most, and then after that, you may take a look on people's comment. Okay, so this computer is fast. That one is very good. That one is like something like that. And then after you find something you want to buy, you may put it into shopping cart first. Wait until you have the salary and then make the order. And then at that time, you may check the inventory. Do we still have stock? And then after that, we go to make the payment and then delivery. All right, billing and then delivery. So traditionally, everything in the sandbox. Let's take a look on some drawback here. We put everything in a single database. When we develop, okay, likely use same programming language, same version. When you want to test something, it's really hard to test all the component. One component, suppose you want to add more resources to shopping cart, you can add more resources to the machine, but really hard to go directly into the shopping cart, right? So by breaking them into microservice, I should say here is not really microservice. The concept is breakdown. Here is kind of serverless oriented architecture, so that we break down into small service. Okay, so we have your home page. The first benefit is we can use different database. All right, this one's still Oracle. This one could be relational database, or this one could be DynamoDB, could be Elastic Cache, key value database, document DB, and then we still have the communication. All right, between those microservice. So could be API call, could be messaging service. And then, yeah, we still do the same thing, search and put into shopping cart. You can actually use, yeah, say for example here, those team is very strong in Java. That team is relatively strong in Python or different version. Easier to add resources. Come back more technical. Maybe here, we still use EC2, the virtual machine. And then in the shopping cart, we could use, say for example, Lambda function, all right, for that service-oriented architecture. And then here, maybe you use some containerized application like Kubernetes. Okay, so easier to break down, use different technology. Again, we break down from free-tier application into smaller service-oriented architecture. And then finally, focus on one function. In our developing class, actually, we develop directly using microservice. I can name some service we discussed in our developing class. We use no EC2, no RDS at all. Just focus on, we can still make the web application. However, we can have actually the Lambda to run the code logic, API gateway to actually handle the HTTP request. And then we use DynamoDB as the database, the object restore in S3, and the front end, the home page, we actually use S3 to handle. And then we also have authentication. Still full features application. However, could be, break down into microservice. And a lot of company already doing something like that. So next practice we are going to talk about is CI/CD, and I'm going to do some demo here. First of all, for CI/CD, again, we integrate new features to our application. So we have the code stage, your application code, and then we build something, build some artifact, output file, store in somewhere else. Could be S3, could be other place. And then we test. For test, we want to say something. Traditionally, not in the cloud, 20 years before, 15 years before, we also have some developer, right, at that time, develop some application, just some story to share. When they test, no problem, no bug, no issue. But when they go live to production, they find some issue, some bug. And then when we talk to the developer at that time, they mentioned, oh, it's worked 100% in testing environment, in my environment. I heard that for more than 20 years, all right? The key reason is that the testing environment is a little bit different from the production environment. Maybe the CPU is different, the motherboard, the driver, whatever different, okay? The hardware is different. But by using cloud, we can have exactly the same environment for test and production because we use code to spin up everything, all right? So that's why much more stable, much easier to find order, but before you go to production, all right? So continuous integration. And then for CD, yeah, actually, we will have two terms. Continuous delivery. Normally, before you roll out to production, you need some Superman, some senior engine to approve. We need some approval before we go live. And then continuous deployment, if we are talking about this one, actually, they directly go to the production automatically, but finish all the tests, finish all the stage, all right? So if you take a look on some process inside those phase. For source, most important is our source code, the version control, the permission control. All right. So you may have still a few developer, all right, work together with the code, right? So in that case, you make some change, they make some change. You may make your final version, and then the other one final. Which one is the really the final one? So we need to handle that version, and then we build the compile code, or nowadays the container image. We may run some unit test whether the code function well or not. Can we identify any invalid input? Can we really do our job well? So and then we do a lot of tests, stress tests, security tests, performance tests, and then hopefully we roll to production, and then we direct traffic to the production environment, and then we can monitor the whole architecture, whole infrastructure. So now let's take a look on some tools. If we talk about tools, again, tools is the least important. All right, when we talk about tools, yeah, of course, code, a lot of people store their code in GitHub, but you can also store in another third party, Bitbucket, GitLab. And of course, if you use AWS, in my demo later, I will store the code in code commit. All right, it's just Git repository. So we have the source control, version control, permission control. And then after that, we can build artifact. Again, third party, you can use TeamCity, or you can use Jenkins. Jenkins can pretty much do many things, all right, in the CI/CD, especially in the on-prem environment. But if you use AWS tools, you can use code build to build our artifact, to build our container image. And then to test, again, third party, or you can use Jenkins. There's so many test tools, in the cloud you can use. But in AWS, if you want to test something, likely you also use the code build. And then to provision, if you provision the environment, likely you can use CloudFormation directly, or you can use some third-party tools, AWS tools, to indirectly work with CloudFormation. A lot of companies nowadays use another third-party tools called Terraform. All right, much easier to write, maybe much more highly compact. In CloudFormation, 1,000 line, here maybe just 100 line, you can do similar things. Okay, much easier to work with. So in order to deploy, actually, you can use code deploy to deploy our code to EC2, to on-prem environment, to Lambda function, and then to ECS. If you play with Kubernetes, we have some project work with Argo CD, Flux CD, and a lot more. You can search from the Cloud Native Computing Foundation. For monitoring, if you monitor the machine, we can use CloudWatch. However, if you use Kubernetes or some open source monitoring platform or features, then you can use Prometheus. All right. And then if you look up there for the orchestration, we can use Jenkins, GitLab, other third party, or on AWS, we can use the code pipeline. All right. So let's show you a demo. Go back to my AWS account. So in my demo, I show you the CI part, and then in the DevOps class, we actually have all the pipeline, including CD, including approval, including everything. So if you take a look in my AWS account, first of all, let me just go there, code. Okay, if you search code, you can find code commit, and then let me get everything first. Code build, and then code pipeline. And in my example, I'm going to work with the container image. So that's why we use the ECR. All right. So if you take a look in my code commit, this is my repository. I have a few, code repository. So this one is called my app repo. When you take a look in the my app repo, I just have 4 files. All right. So if you take a look, yeah, this is just an index page. All right, blue color. All right, and then I have another page, and then light yellow. All right, page 2, and we have a link go back to the first page, just like this. And then we build the Docker file, all right? So the Docker file is actually, to create a container image. So you can do everything from yourself, but I'm kind of lazy. I just borrow the NGX. If you never heard about NGX, NGX is in the container world, the ingress controller, just like the firewall inside your container environment. However, I just borrow their web page, okay, and then copy the image and page 2 into the NGX. And then this is our code. And for code build, they actually look at a file called buildspec.yaml. So for the buildspec.yaml is actually what they are doing. Okay, so log into ECR. ECR is just like Docker Hub, is container image repository. So we log in first, and then we execute the build command. The doc actually refer the Docker file, and then finally we push the image into the ECR. All right. So here actually they build a new container image. Is the script or command to build a container image. And then I create a code build project. So the code build project actually look for this build spec file in order to build things. You can manually trigger the build. So as you can see here, if you see root here, I manually trigger the build. But we can also integrate with the code pipeline. So code pipeline actually do the orchestration to make it automate. So when I show you in my pipeline, actually I just have 2 stage. For a real life environment, you may have 5, 6, 10 stage. Okay, so actually here we detect the source from code commit. Let me edit and show you what's inside. So if you take a look in the edit here, not only you can take a look on the code commit, we support a lot of third party. Say for example, before we see Bitbucket, GitHub. So we can detect, oh, something changed in your GitHub. So if the developer, the small team, change something, we can automatically trigger and build something. All right. So and then look at this repository and the branch, main branch. I will show you also the branch as well later. Okay. And then after that, we detect some change in the code commit in the main branch. Then we build something. All right. Down there, you can actually see we use the build project from the code build, so that actually here we build the container image. We just execute the project, all right, just like this. And then if you want, you can add more stage here. Let's say I want to add some test stage, all right. And then if you go inside, you can take a look. Actually here, a lot of integration. For testing, you can use code build to test. You can use Jenkins also. You can also use device farm. Just imagine, a lot of mobile device on AWS side to check whether my mobile application work in those mobile device. Test the UI and a lot more. All right, you can even invoke the Lambda function, deploy to different environment, deploy to CloudFormation, deploy to Elastic Beanstalk, ECS. Okay, and then we can also have manual approval. So here is actually the orchestration. So let me show you really make some change. And in order to do that, let me show you in the ECR. I already have this image, and I did this demo a lot of time. All right. So the latest image is having the second page yellow color. All right. So let me do everything from scratch. So now I create a single EC2 machine as a developer. All right, as a testing machine. Okay, as the CI process. So now let me create the developer machine, just Amazon Linux, and then I just keep everything default. The keep here in order to lock in that machine, and then the VPC where I'm going to put it really doesn't matter. And then I need a security group with a port 80 because this is a website. We don't care about the 443 and the certificate, all right? And port 22 for me to remove, all right? So I just keep everything default. And the most important is we should have the role in order to do your task, work with the ECR, work with the code build, something like that. So anyway, I just use a relatively high privilege role in my demo. Okay, so after that, I will, just, it takes around 10 seconds, 15 seconds in order to create that machine. Okay, that's the development machine. Actually, you can use Cloud9 as well. Cloud9 is online IDE. But anyway, come back to our topic. And then I'm going to connect to that machine. That's a new machine with nothing. I want to show you from scratch. All right. So go back to my, machine. Yeah, it's still creating. So normally it takes 15 seconds. Now I already logged into the EC2, the Linux machine on my AWS account. So I don't need to configure the AKSK because I already create a role and then set my default region. All right, so in this case, let me just take a look if I can run some API call. So I can list my S3 bucket, that's perfect. So it means my credentials works well. And then if you type Docker, I don't even have the Docker install. So now, because I'm going to build the container image, I need the Docker, all right, for my CI environment. So let me just install the Docker, all right. Lifetime will really take some time. All right, so after we install the Docker, and then I'm going to start the service, make the service auto start even after reboot. All right, so just two more commands. Here, start the service, and then make it, even start after restart the machine. So I also add the Docker, the EC2 user into Docker group so that I don't need to type sudo every time. Relatively lazy. All right, but anyway, let me log in again. Now I can type Docker version without sudo. So for this version, I'm using this Docker version. All right, and then you can take a look on detailed information. So at the moment, I don't have any container image. And then I don't have any container running. I have nothing. That's why I need to log in to some Git repository like GitHub, like our code commit. All right. So now let me log into our ECR. Sorry. So go back to ECR, and then the command is relatively long, but you don't need to remember. You just copy and paste. If you go back to the ECR, the container registry, and then you can find the command here. The ECR login, Docker login. Actually, they use just standard Docker command. So I just copy and then come back here and then log in. And then you will see login success. Okay, you need to log in. I can log in because I'm using the role. Okay, if you check from here, AWS STS get caller identity, then you can see what role you are using. I'm using a super admin role, so I have privilege to log in ECR. All right, and then after that, I'm going to pull the image. All right, pull the image from my ECR registry. So it takes a few seconds, and then after that, I can show you. If you can see now, I have Docker image, but I don't have, the container running. Okay, so now I'm going to run it. All right. So when I run it, you can see now I have the container running. Okay, and then what should I do next is actually check the IP address of this machine, the new machine I create for testing the new features. So when I show you the IP address here, all right, so you can see, yeah, this is, if you want to try, you can go together with me just using any browser. Could be your phone, could be Google Chrome, Safari, IE, whatever. Just type this IP address 52.221.232.83. Okay, then you can actually visit this website. All right, it's very, you know, just plain, or easy website. So and then is you just see the image, and then if you take a look on the page 2, and then you can see the color is light yellow. All right, so this is just running from container. And then next, the topic here we talk about is DevOps and CI/CD. What if I change the code? Let me change in both way. Normally, developer will change here in their developing machine, in their Visual Studio, in their Cloud9, in their Eclipse PyCharm. But I want to show you the versioning as well. All right, the source control as well. So suppose now I have a relatively junior developer. So the story is like this. Let me use another browser to pretend I'm using another user. So let me log in. Yeah, log in again by using a Git user. All right, I need to copy the ID. And this is my account number. All right, just copy. Go back. Let me put everything together. All right. So in that case, if I log in to this AWS account and then use the Git user, all right. And then after that, this user, developer, make some change. So he or she go to the code commit, and then we can directly change if you have permission. All right. What if, just imagine this user do not have permission to touch our production code? Because when you change something, automatically the code build, code pipeline, build everything, maybe even push to our production environment. So in that case, we talk about branch. So we have the main branch. We can create another branch and just change in the branch. Okay, so let's say this is branch 1 from main branch. Okay, so actually you can imagine we have 2 copy, 2 version. All right, we don't want the junior developer touch our main production version. So if you take a look on branch 1, we have all this file. Of course, again, developers should change not in this console, but in the development machine. So if he or she go to page 2 and then change something, let's say to green, okay? Just imagine this is a new features in real life environment. Of course, you add some new features to your application, but you imagine this is just an example, change something, okay? So this is Git user and Git user at example.com, something like that, to green. So this is for your team member. Oh, I make some change. What are those change? The message, all right? And then after that, actually, you just change the branch. If you go back to main, you see it's still yellow. All right. Again, if you go back to main, still yellow. Okay, let me show you again. Okay, you didn't commit. And the junior developer can actually make a pull request. So try to merge, let's say from branch 1 to main, and make the comparison. Okay, actually, you can do this in Git command. But anyway, to green, something like that. All right. So I'd want to merge, and then you can actually take a look which file, what are the changes, whatever. And after you make the pull request, of course, we need some approval. Okay, so if you really merge, there are a few different ways to merge. Do you want just a single timeline, or make another, like the branch and then commit together? So it's just some minor settings. All right. So we say, for example, here, we don't have permission because this is the junior developer. All right. If you really want to change, maybe you need some approval. So that's why we go back to another relatively senior DevOps guy or developer operator, whatever, senior engine. Okay, so now let me go back to the code commit, and then you can take a look. Pull request. Oh, Git user want to do some change. All right, and then you can actually have some approval rules. Suppose you need the department head of developer and department head of operator both approve in order to make your change to your main branch, the production code. All right, you can do something like that. Okay, and then here I just merge them. I click the same button, but actually since I'm the higher privileged user, I can do the match and delete the branch one after that. So after you click it, you can see in my branch, no longer I will see the branch one because already merged together. And then in page 2, you see it's green. I did just like this. And if you go back to our code pipeline, you can see just now, okay, they detect some change. And then they ask code build to build the container image automatically. Okay, so you just modify your code, but every other thing happen automatically. So it takes some time for the image to build. And normally in this area, I will clear everything. Okay, so if you take a look, Docker ps -a, and I'm going to stop this container, Docker container stop just this ID or the name. And then after you stop, you can remove. I just clear everything, okay, because I don't have actually the Kubernetes environment to run for this demo. All right. So if you take a look at the container image, I can container image remove the ID here. All right, and then now I remove everything. Okay, I don't have image, I don't have container running. So normally when I go back to here, let me do a refresh. Normally just take 2 minutes. Oh, still building. Okay. Anyway, so if you go back to the code build, you can actually see the build history. Oh, just finished. Okay, and then go back to the code pipeline. They finish. And if you take a look on the ECR, then you can see actually, refresh. The time is just now. All right. So let me do it once again. If I just run another, it will pull the new image. Okay. So before the color is light blue for the first page, yellow for the second page. And then if I go to the same IP address, okay, and then refresh, you can see it changed to green. Okay, what I did just change the code. But the most important is you should have authorized, permission in order to change the main branch because everything happened automatically. All right. So I can also show you how it looks like if the developer change here. Let me do it just quickly. All right. And now let me do it in this way. So first of all, I need to install Git. Okay, install the Git. Yeah, if you're a developer, likely you work with Git command rather than using the console. Then we need some AKSK or credentials. So we have the credentials for the user, and then just double check the key are there. All right, and then we clone the repository. Okay, clone the repository from code commit to my local machine. So after you do this, just a few sentences, then I can show you the repository is already downloaded from code commit. So we can also change from here, my app repo, and then you can actually see this file. All right. And in order to make some change, yeah, I just specify what are the username, password. Let's say this time it's not Git user, it's me, Brian. All right. And then, of course, we better make some change. So if I make some change now, instead of green, let me make it to gray. All right. So after that, I save it and use the standard git command, git add. All right. And then git commit to gray color. All right. Just change some other. And then after that, we can push, git push. Okay. So after you push, if you take a look on the online version, all right, now this time I just push directly to the main branch with the correct permission. All right. Of course, in real life, we should once again create another branch, change their first approval, and then move to your main branch. But now let's just simplify. Okay, you already understand those concepts. So if you go to the branch and then take a look, page 2, you see it's already changed to gray. So it changed in your IDE device rather than in this console. All right. And once again, if you take a look on the code pipeline, they will build another. And this time I don't need to clear everything, download again, and show you gray color. I think you get the concept. Just a little bit different. We can also change from our, IDE device or, whatever PyCharm Eclipse work with your Git repository. So come back here. Before we take a break, we can take a look. In my demo, actually, I just show you the CI part. Okay, but you can actually get the key concept, automate everything. We just change the code in the code commit, and the code pipeline detect there is change, and then we build the container image. All right. Of course, you can use third-party Git repository. You can use other build tools. You can use not code pipeline, but Jenkins, GitLab as orchestration. And if you have, say, for example, those production machine running on EC2, Lambda, or even Kubernetes, we can actually just change the code and deploy to production. You just add more stage and then use the right method in order to deploy to different, individual service, okay, or technology. So let's take a look on some more example. All right. This example showed you not everything AWS. Maybe we still use code commit. We still use this as Git repository. Suppose many people use Jenkins in their on-prem environment. When they go to AWS, they still want to use Jenkins to do the orchestration or Jenkins build server. However, spin up a lot of Jenkins build server costs you your EC2, your compute resources. We can integrate with code build. We can use still your Jenkins job, but use code build to build those, to replace the Jenkins build server. Still helps you serverless to build everything, all right? And then you can store in S3 your output, your artifact, all right? And then another example, just example, all right? Then you can see using code pipeline, our source code, say for example, put it in S3. But again, it is better for us to put our code, our source in Git repository so that you can use the git add, git pull, git command in order to interact, to develop. And then we can deploy to some test stage first. Okay, maybe just a few machine to do the testing. We can invoke Lambda to run whatever customized code. And then after that, we deploy to production. Maybe production is a larger environment with multi-AC deployment, bigger instance type, something like that. All right. So another example is quite similar to what I did before. The code commit, we modify the code and then the code pipeline build the container image. This is exactly what I'm doing. And then we can also integrate the CloudFormation to create a new ECS environment for tests, and then push after finish all the tests. Next stage, how are we going to roll into our production environment? All right. So this is again just some example. So now let's take a short break, 5 minutes, and then I'm going to pass the time back to Tracy. Tracy, are you with me? Hello, Tracy.
Hi, Brian. Yes, thank you
Yes.
so much for that informative webinar. And let's let everyone take a quick 5-minute break. And in the meantime, we are going to launch a quick poll, and we just want to invite you all to participate during this break. Doing so helps us know how we can better serve you by telling us who might be interested in information or in taking some additional training. So you can check that out on your screens. There it is. Again, it will just take you a few minutes, and this way we can further serve you better with all our courses and webinars. In addition, we have a lot more informative webinars coming up. You simply have to go to netcomlearning.com /webinars in order to register. Okay, break is over, Brian. We are going to bring it back to you. Okay, Brian. Hey, Brian, are you there? Okay, we'll just all let you take this poll for the next couple minutes, and then Brian will come back on and finish up the webinar. Thank you. Okay, we're wrapping up the poll. We want to thank all of you for those of you who are participating. And again, we'll show that again at the end of the session. But for now, I'm going to give the screen back to Brian, who will finish up his most informative webinar. Go ahead, Brian.
All right. So yeah, you should be able to see my screen now. Can you see? All right. See my screen now?
Yes.
All right. Okay. So let's go ahead. Okay. We just talked about the DevOps, and DevOps, we have a lot of practice. Say, for example, before we talk about the CI/CD, and then after that, here we talk another important type practice called infrastructure as code. Okay, it's also the practice of DevOps. So actually, the tools is using CloudFormation. CloudFormation is a key service to make us infrastructure as code. So let's understand some terms first. Next, we will talk about CloudFormation template. Template is just a file. It could be JSON, JavaScript object notation, or it could also be YAML. All right. So here we state what you want to create in AWS Cloud, and then you submit this CloudFormation template into the CloudFormation engine or CloudFormation as service, and then they will create stack for you. Stack is actually collection of resources. The resources you create on AWS, it could be any resources like EC2, VPC, RDS, S3, etc. Okay, so and then let's take a look on its structure. We can also provide parameter. Parameter is just placeholder inside your template, so that we can use a single template to build different things. Maybe this time I'm building a development environment. I just want a very small machine to save costs. And then next time I use a larger machine. Okay, so it's just placeholder. We should use CloudFormation to create your resources, to update your resources, and then also to delete everything or import the resources. And then I can say drift detection is really the key for people change to CloudFormation. Really affect a lot of customer. Okay, from manually building everything from console to finally use infrastructure as code, mainly because of drift detection. Okay, so let's go ahead and take a look. And then first of all, why should we automate? In order to automate everything, we can reduce human error. Think about if you want to build a virtual network, the VPC, and then the public subnet, and then the gateway, the load balancer, the website, and then application and database, and then security rules, and then the route. So complicated. If you really build everything yourself, even if you're super expert, you might take hours in order to build it. But by using CloudFormation, it could just build in 10, 15 minutes. All right, much faster, much more stable. Human to create two machine, no problem. If you ask a human to create 2,000 machine, likely some typo, do something wrong. All right, so much faster and more important in our DevOps concept, identical environment for you to test and run it in production, so that less likely you will find all the bugs in production environment. All right. You can also think about CloudFormation just like the application code. You can put it into our code repository. All right. So that when you make change, we change directly to the source code. Your infrastructure is also code. All right. Think them just like the application source code. And then we can actually validate and then use the CloudFormation to configure to change everything. All right. So again, understand some terminology. All right. We call it infrastructure as code. We have this CloudFormation template. This one, the format is YAML, the indentation. All right. So here we are going to create VPC Internet Gateway. Of course, you need to set the properties. are the name of VPC, what are the subnet IP range. So here you should include, the properties as well. So after you submit to CloudFormation, and then they can create something like this, just anything, VPC, multi-ASAT, auto-scaling group, load balancer, internet gateway, together with Route 53 and CloudFront as well. It's just an example. You can create other things like API gateway, Lambda, DynamoDB, together with whatever serverless service as well. All right. So here, if you take a look inside the JSON or YAML, there are many components, but only one thing is required: is resources. What are you going to create? Is it VPC? Is it RDS? Is it EC2? All right. And then you may have some other component, like before we mentioned, the parameter is just a placeholder. So we can, at runtime, actually type it. Or you can also call the parameter from System Manager parameter store. Okay, so that you have all the preset answer, preset value. We just call them rather than manually type everything. You can use mapping for static variable like the AMI. Any single region, the AMI ID is different. Even if you create the same Amazon Linux, the same Microsoft Windows. So that's why you can map all this into your template. You don't need to type the AMI ID yourself. All right. And then you can provide condition. Condition is very powerful, so that you can specify, say, for example, you have the production environment and then also the development environment. If you select production, then they build maybe bigger instance, multi-AC, and then you have some whatever standby machine. And then if you select testing or development, smaller, no need multi-AC, something like that. And then if you see the output is just the output you want to return back to your caller. So these are all the optional component. Only resources is required. So in the CloudFormation console, of course, you can work with console. You can also work with actually the command line. You can also import resources into your stack. Okay, you can use one single stack to build everything, but 1,000 line is not easy to troubleshoot. And inside your CloudFormation stack, you may create the credentials, permission, IAM, and then VPC, backend database. Maybe not everybody are expert in everything, right? So it is better for us to make them into a module approach. So just like this, you may have multiple stack to define permission, multiple stack, multiple template to define VPC. So when you really want to create something, then you just call. Okay, say for example, you have this type of network, different types of database, different types of backend, and then different types of front end. So maybe now I just create a testing environment. I just need this permission, and then I just need single ASAT. We don't need multi-ASAT to save cost. And then what kind of database? And maybe another time you call different module. So you break down the thousands line into different smaller component. So easier to write, easier to troubleshoot. So now here, let me show you in the CloudFormation console. So go back to my CloudFormation service. How to start? Okay, we can go to CloudFormation here. So by going to the CloudFormation, I already have some, CloudFormation for my many class when I teach. Let's assuming we start from scratch. So if you click here, new resources, I'm going to use the console, but you can definitely use the command line and then also the SDK to do it. And then here we have some sample. All right. So by using sample, easier to start, easier to follow, right? Easier to change. So here they may have, say for example, build a work. Let's say we want to build a WordPress portal, something like that. You can build Windows, you can build Linux, Apache, MySQL environment, and you can also create multiple ASAT. So now let's just use this. Actually, this is a template available to Propic. Okay, and if you click the design view, instead of just building this thing, I want to change. all right, change something inside, and they can actually have the graphic, like what you see is what you get. And then if you take a look down there, the template, for this template already, as you can see, 400 line. And if you take another box, the radio button, YAML, yeah, 700 line. So you can just go inside and try to change it, all right, instead of build everything yourself. What if you really want to start from scratch? Okay, let me show you, all right, instead of just modify this thing. So now let me, yeah, do it from scratch, and then create template in Designer. When I click this button, you can actually see now in my template I have nothing. Okay, so what if, just like the previous example, I want to create a VPC, also create the subnet, the EC2, let's say also the RDS. Okay, so you can just drag and drop. Let me show you. Now I have just a few line talking about the version. So if you want to create a VPC, you just find the right place. You can search, you can actually find it from here. Let me drag the VPC. When you drag the VPC to the design plane, then you can actually see, oh, they already help you write 29 lines. Okay, so they already also provide the name. If you don't like this name, you can change. I want to change it to VPC 101. All right, and then you can also change back to YAML. All right, so here the YAML format. Okay, your choice, JSON or YAML. And then after VPC, we need subnet in order to contain the EC2, right? So just find subnet. Oh, subnet is here, and then I jet it into the proper area. Okay, so here is your subnet. Once again, if you don't like this name, you can change. That's the subnet. All right, and then after that, suppose I want the EC2. All right, so this is the instance. Okay, and again, here you can change the name, and they already make the reference. Reference help us to control the order. We should create VPC first, then subnet, then EC2. You cannot just create the EC2 without subnet, right? So here, the EC2 actually reference back the subnet. Okay, so here they can help you control the order. And of course, you need to type the properties. What is the name, and then what are the settings, sizing, whatever. All right, otherwise it will fail to run. Okay, and suppose I want a database RDS in the same subnet. So you just go to RDS, here. Okay, so if you go to RDS and then drag the RDS here, and then you can see the database also here. You can change the name again. All right, so this is how we start from scratch. What if you want to find some more example? Okay, so you can go to this website, AWS Quick Start. Okay, but already AWS Quick Start changed the name to a successor called Partner Solution. So if you go to here, there are more than 400 partner solution. Okay, some of them you can find the CloudFormation template as well. All right, so if you search, before we talk about WordPress, right, you can just try to search anything. All right, so here you can see, this provider build the WordPress, and then you can view the deployment guide. Likely, you can find after everything, maybe redirect you to some GitHub or whatever link. You can download the CloudFormation, and then they will also mention what are the costs, okay, in order to build those things. And then there is the diagram, or what are they going to build. It's quite complicated, right? You can see public subnet, private subnet, together with NAT gateway, S3, even cache, and Aurora database. Okay, you can search some other database. So it will be easier for you to start by using these tools rather than do everything yourself. All right. So when you want to change something, instead of change directly the resources, we should also use CloudFormation by issue the change set. So we should use code to build things, and use code to change, to update, and use code to delete everything. All right. So by doing that, you just go to CloudFormation service. Let me just show you how it looks like. Go back to my CloudFormation. All right. Suppose some CloudFormation template. I can go to here. All right, and then create a change set, and then they ask you another template, another code to replace. You can also work with the designer as well. Okay, and then before you really make the change, they can show you actually what are the affected resources. Originally, you have the stack, and then you can issue the change set. Let's say I want to change the instance type, I want to change, add more subnet, change the security group. And before you really change, you can actually view it from here. All right. And then finally, you find that no problem, and then move out to the production environment. All right. And then this is use CloudFormation to change. And to delete, if you go to CloudFormation and then click this delete button, everything gone, no matter how many resources inside. All right. So you can actually take a look the CloudFormation. What are the resources create? What are the parameter? What are the output? Okay, and then what are the change set? Just keep using code to make changes. All right, and then next, another very important concept I want to share with you is drift detection. Okay, drift detection have been there, I think, since 2018. Actually, before that, we faced some class, some, CISO, I remember, all right, is the security chief information security officer, asked me this question: how can we verify our existing environment is equal to the golden template? All right. So for security team, security risk, what if somebody, after we create everything by using CloudFormation, and then the environment is very good, it's golden, and then if somebody with permission go inside, let's say to open the firewall to the public, make some change not according to security best practice, okay, because so many people might have permission in the production environment. So before 2018, we have no features like this. You might need to write a lot of coding, but now we have this drift detection. Drift detection actually detect whether your existing environment equals to the template. If you find it in sync, no problem. Okay, yeah, you are confident that your environment is still golden even after a few months, 1 year. But if you see drift, you can see something change. Okay, maybe unauthorized change, and then you can actually find what are the changes. Let me show you. All right. So if you actually, this concept, this topic really changed a lot of company. Okay, in my experience, before they manually build many things, and then the security team want to do the control, want to use these features, and then finally they actually move to infrastructure as code because of this reason. And then if you take a look in this CloudFormation, let me use this as an example. Where to see the drift detection? Okay, here you can click detect drift if you have permission. Normally it takes some time, but anyway, in my environment, we have just a few resources, just seconds. Then you can already view the drift, and you can take a look at the time. And if you see in sync, then you are confident that your existing environment, you may have many machines, a lot of network, database, front end, whatever, is equals to your template. Then the security team, risk team will feel comfort. Okay, we are go under the guideline. All right, and then another one, I just purposely delete something not relevant. So here is another template, and if I view the drift, and here you can actually see, it's drifted. Okay, and you may have a lot of resources. You can actually find, what are drift. Okay, is it related to security group? We open to while the SSH whatever port to the public, so you can chase. And then next step, you might go to CloudFormation, Cloud Trail, who make the change, okay, and then find out the reason, okay. And what if, somebody changed something yesterday night and then do something bad? All right, say for example, use the machine to do the Bitcoin mining, and then after a few hours, change back to, you know, uh, compliance environment. Okay, just have around 8 hour change for doing something back, and after that, before morning, before everybody go back to office, and then change back to a good environment. So you can even integrate with AWS config. AWS config can help you actually monitor your resources over time. Okay, so I already have some rules. Let's take a look here. If you take a look, let's say in my example, the EC2. All right, so these are the EC2. You can take a look on the resources timeline. Who did any change? All right. So as you can see, yesterday, the day before, last week, we have some change. You can actually see what are the changes. So by using AWS config, actually this rule, let me show you. I can say when I firstly teach AWS many years before, they just have around 40, 50 rules. And now they have more than 200. Okay. So let me just briefly talk a little bit here related to security, related to our DevOps as well. So you can say, for example, I want everything encrypted. So you can check what are the EBS volume not encrypted. Think about, you may have 2,000 machines. You don't want to check them manually, right? So we have the rules help us to check. Okay, and go back to this topic. So if you take a look on drift detection, all right, drift detection, you can enable these rules to see whether your CloudFormation is drift over time. All right, so that actually helps in order to monitor your environment. And again, this is the key reason why people move to infrastructure as code. But I want to share with you in production, in real life. I would say many years before, people directly work with CloudFormation. But nowadays, relatively, they will work with some other tools rather than rather than working with CloudFormation directly. All right, so there are a lot more way in order to work indirectly with CloudFormation. So say, for example, if we talk about ECS, EKS, right? If you install the ECS, CLI, ECS, EKS, CLI, actually, when you use the command, type something, build the environment, under the cover, they are still using the CloudFormation. All right, just one single relatively long command, they may equals to a few hundred lines in CloudFormation. All right, but actually the EKS CLI help us to build a Kubernetes cluster on AWS, and this one is building the ECS and some other on AWS. Nowadays we have SAM, serverless application model. So it's an open framework. By using SAM, we build the serverless application, like using the API gateway, Lambda, the Cognito, S3, DynamoDB, blah, 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 without EC2, without even the VPC. Under the cover, you use the same template, use that YAML. This is way more compact than CloudFormation. Maybe just 10 line here equals to hundreds of line in CloudFormation template. All right, so you work with the high level compact command rather than directly using CloudFormation. And a lot more I can share with you. If you use CDK, normally for developer, they are very good in developing their code using the Java, Ruby, Python, right? So if they want to create something in AWS, of course they can use CloudFormation. But developer, they may need to learn CloudFormation. They may not want to learn new things. They just want to focus on, their development their programming language. So by using CDK Cloud Development Kit, they can use their own language, Java, Ruby, Python, all right, and a lot more. And then under the cover, they actually also again way more compact. Use CloudFormation to build things. Okay, and another example before we talk about that, another company, HashiCorp, have the Terraform. Really, a lot of people use Terraform. Terraform is infrastructure as code. We can use again way more compact if you like to build things on AWS. And Terraform not just support AWS, but also support other cloud like Azure, Google, etc. So so that you can build using one types of language to build things in different cloud. If you just work with CloudFormation, you can only build things in AWS, right? So now I'm saying we have many method, many tools, rather than directly work with just CloudFormation, much easier to work with. Okay, but anyway, still infrastructure as code. Use the code to create everything, and then we can have the source control, permission control, version control as well. All right, so this is really the CloudFormation, okay, related to infrastructure as code. All right, and then next, another practice is actually related to the monitoring. Okay, traditionally on AWS Cloud, we say monitor using CloudWatch. By using CloudWatch, we can monitor the CPU, memory, hard disk, network of your environment. I can show you a little bit. Let's say, let me log out. We can even build a dashboard, set the alarm, but this is relatively traditional way to do the monitor. Okay, so let me just log into another AWS account, and then you can actually go to CloudWatch, and then we have many metrics. Let me just show you the dashboard. So when you take a look on the dashboard, you can actually see the machine running on AWS, and then on on the Azure, all right, and some on-prem environment. You can take a look over time, let's say 6 week, okay, and then see the pattern. And then you can also actually set the alarm, all right, so that anything alarm you can see, you can take a look. All right, so in that case, let's come back to here. But the new way is nowadays we may have a lot of container running, okay, in your environment. We might also have serverless. How can we gain insight to those applications, to those container? All right, if you take a look on the open source world, a lot of open source application cluster, they use Prometheus. Okay, it's just open source standard metric in order to monitor your containerized environment. And by using AWS, we have something called Container Insight. Actually support those Prometheus metrics. So this is just screen capture in our EKS class. We will have lab and demo and inside. So here I just want to show you. You can actually see inside what are the port, what are the surface. If you edge over the mouse, you can actually see what are the resources those container are using, not the machine. Okay, because in a single machine, you may have tens or even hundreds of container running. Is those container hit some limit, not the machine? You can actually take a look in details. Okay, and then for microservice, okay, we are talking about so many microservice interact with each other. What if the latence, the error, we hit some rate limit? All right, so here in AWS, we have, let me briefly talk about this one, X-ray service. X-ray is really, really good for us to monitor the microservice. So if you are using AWS, the API gateway, the Lambda function, Just go inside, you can enable X-ray. But for your application, you might need to use the X-ray SDK, start the X-ray daemon service, and pass those data, those end-to-end trace data to AWS. Okay, so I just show you some example. You can find, they can build a service map like this. Let me just enlarge and show you. So your client may go to some front end, could be API gateway, all right? And then it become the REST API, and the API gateway, the front end may talk to some other microservice, like Lambda function, like DynamoDB. So the ideal environment is you see everything green. Green means 200 success code. However, if you see something red, maybe there is some error or fault. Okay, normally yellow for 400 error, 500 is actually the red color. So you can easily trace what are the reason. So as you can see from the API gateway to this component, actually we don't have problem because all green. But maybe here we see some yellow, we see some red color. And not only this, but you can also see sometimes purple color. Let me just try to find some purple color. Purple color, luckily, you hit some way limit. Let me just enlarge this one to show you. As you can see here, purple color. Maybe in many requests, we hit some limit. All right, so this is a relatively new way to monitor our microservice and then the container as well. All right, so this is really the new method for monitoring. All right, so you can see the breakdown, you can see whatever having issues. Okay, so this is all for my part. Let me pass back the time to Tracy. Tracy, thank you.
Well, thank you, Brian, for that most informative webinar. And we are going to be launching a quick poll soon, and we're going to get to the Q&A in just a few minutes. So keep putting those in. And before we get to your great questions, I want to pass the presentation rights over to Amitash, our vendor manager, who's going to introduce you to some of our fantastic promotions and other webinar related courses. Okay, go ahead, Amitash. You've got the webinar.
Thank you, Tracy. So I believe this was an insightful session on AWS DevOps. So here actually I'll be introducing you to Netcom Learning as one of the leading cloud training companies in USA. So yeah. So this is a brief introduction of Netcom Learning. So we were given the award of #1 training partner of the year from Microsoft this year. There were over 3,000 contestants from around the world participating in this competition, and we were the #1 training partners. And so far, since 1998, we have been here in the industry, and we have trained over 16,000 enterprise customers and enterprises, and 175,000 plus professions have been trained from our company. So we have also won the top 20 IT training company award from the trainingindustry.com this year. So this is about, a brief introduction about Netcom Learning. And so for people who have attended today's session, if you require a recording of the session, it's available in the handout that will be given out to you. So this is the link to, this button has the link to the recording. So you'll be able to access the recording of today's session as well. And this webinar was just the first step of a larger journey, a cloud learning journey. So developers and system administrators who are interested in taking up the DevOps with AWS, there are many courses that we have. We can start with the developing on AWS and systems operations on AWS. There's also the DevOps engineering on AWS, which we have a course that is running from January 23rd. And for beginners, there is the AWS Cloud Practitioner Essentials. And we also have the Technical Essentials and Architecting on AWS courses that we have in January and December. So the links to the same have been provided, and again in the handout. So you'll be able to click on this link and you'll be able to learn more about these courses that we are offering. So in the similar lines, we also have free 2-hour training, the AWS Discovery Day, which will help you learn more about AWS capabilities. The first one is the Cloud Practice Essentials, which will be held on a particular date. And we also have a free on-demand training course, which is a pre-recorded one. So it will be related to data warehouse on AWS. So you'll be able to access this training course as well by clicking on this link. And there's also an interesting blog that we have from our end, which you can access. So yeah, we are heading towards the end of the year 2022. So for enterprise customers who want to start their 2023 stronger with a comprehensively trained cloud team, we have a great offer that we have, a gift card promotion. So with this gift card, actually, if you purchase a course which is worth more than $1,000, you'll be getting a gift card worth $100. It will be an e-gift card. And if you purchase a course which is worth more than $5,000, you'll be getting a gift card which is worth up to $500. So you have two options. Either you can pick this e-gift card, which is of Amazon, Microsoft, and American American Express, or you can go for a what do you call the discount, so that like if you purchase a course which is $5,000, you'll get a discount of $500. So you can choose that option as well. So Netcom Learning trains enterprise customers across various technologies. So you can choose any of our course and you'll be able to get this discount from us. So to access this offer, you can click on this link, get your gift card. So, and this offer is valid till December 31st. And you can actually purchase a course from us before December 31st and schedule a course before March 31st, 2023, and you'll be able to get this offer. So this is about the gift card offer that we have. This is the year-end promotion that we have. So the next one is actually, you can also go for enterprise customers who are here, who have taken up a course, who want to take up a certification exam, who are a little bit hesitant. You can actually go for the AWS double shot offer. With this, you can actually purchase an certification exam voucher from us, and you will get a free exam retake opportunity. So even this offer is valid till December 31st. So anyone who is planning to take up a certification exam for AWS, who wants to give it a try, you can purchase a voucher through us, and you'll be getting two chances of taking up the exam. So that is that one free exam retake opportunity will be there through this offer. So to redeem this, you'll be able to you'll have to click on this link, and you'll reach a landing page. Through it, you will be able to get this voucher from us. So apart from this, AWS also offers various training materials which will help you actually upskill your cloud teams. So e-learning is a part of this offering, free e-learning courses. So you'll be able to access our AWS e-learning courses through this link. You'll be able to land on the landing page, and you'll be able to check out various courses, tools and capabilities of AWS. If you're a beginner, or even if you are a professional who is already working on AWS, you'll be able to get access to the e-learning courses that we have. So apart from it, we have a customized private group training that we offer to our enterprise customers. So this will actually help the enterprise customers understand how Netcom Learning works, and how we help companies identify skills gap, and how we provide the training. So we can give you a customized training based on your team's upskilling needs. So this is specifically for enterprise customers again. So to know more about this private group training program that we offer specifically on AWS, you can click on this link, and you'll be getting access to the landing page where you'll have more information related to that. So we have training programs that we've designed for architects, developers, system ops administrators, and various other roles. So you'll be able to get more information about this through this link here. And AWS Learning Needs Analysis. So a cloud team which is actually working on a migration project, or it might be just starting off with through some smaller projects where you're testing the capabilities of AWS. So your learning needs may vary from organization to organization. So there might be different roles within the cloud team itself, and it might be a challenge to actually identify the skills gap and to understand which person requires what kind of training. So to help such organizations where there are like more than 40 plus employees within an organization, we have a special program which is the learning needs analysis. This will actually start off with a simple survey, like about 10 to 15 minutes, where the cloud team, which is working on a particular project, will be given questions. So through that, our team will be able to identify the skills gap within the team, and the kind of, based on the requirement of the organization, we'll be able to prepare a proper AWS cloud scaling plan for you, and we can take it forward. So this learning needs analysis is specially designed for such organizations where there are multiple roles, and we have to identify the skills, and we'll have to prepare a proper plan, and to create a proper footpath for the organizations. We have prepared this learning needs analysis program for them. So to know more about this as well, you can actually click on this link here, and you'll be able to understand more about this learning needs analysis that we offer specifically for enterprise customers. So Netcom Plus subscription is our corporate offering, especially for individual learners. As I told you earlier, apart from AWS, we train organizations in Microsoft, Cisco, CompTIA, EC Council, and various other technologies. So for individual learners in organizations, this Netcom Plus subscription will be very helpful, where a person can actually enroll for a particular and get this for $2,999, and he'll be able to access like 250 plus e-learning courses and 140 plus virtual instructor-led training courses with this just $2,999 offering. So this is especially for the Netcom individual learners, and we also have a similar one even for the groups, which is the Learning Passport. So the Learning Passport is for groups. Yeah. So here we will be actually a company will be able to pay a certain amount, and they'll be able to access 4,000 plus official courses for 12 months. So there are two kinds of packages where it can be in terms of training days, or it can be in terms of training hours. So Learning Passport is specially designed for teams. And to know more about Netcom Learning Passport scheme, you can click on this link, and you'll be going to a landing page where we have more details related to this. Again, this is for groups, the Learning Passport, where a team will be able to learn different technologies, AWS, Microsoft, Cisco, CompTIA, by enrolling into this program. And we also have shared some additional resources here so that our learners can check out related to AWS as well as other technologies that we have. So this is about it, what I had to share. Over to you, Tracy. Thank you so much.
Well, thank you, Amitash, for sharing all of that fabulous information to everyone attending our webinar today. And finally, I want to get to some of your great questions. For Brian, the first one comes from Lewis, would like to know, what's the difference between CloudFormation template and CloudFormation stack?
Okay, actually, a lot of people get confused with these two. CloudFormation is actually the service, to create infrastructure using code. Template is basically the file, the JSON or YAML. Then inside you specify your resources, and then stack is actually collection of resources you are going to build or create based on the template. So in short, stack is collection of resources. Template is just a file, JSON or YAML. So that's my answer. Thank you.
Thank you. Another question coming in from Arthur. Can we use a CloudFormation template to deploy resources to another region and other AWS accounts?
The answer is definitely yes. The terms we use is CloudFormation stack set. By using CloudFormation stack set, we can create resources to other AWS account and other region. And that's actually the best practice, because the source template we can control in a single AWS account rather than distribute it to multiple environments. So the answer is definitely yes. Okay, the stack set is the answer. Thank you.
Thank you. And from Karen, finally, would like to know, can you provide more examples on integrating Jenkins with AWS DevOps?
Okay, in the previous slide, we can see we can integrate the Jenkins job by using code build. All right, so this is the first thing. You don't need to spin up the EC2 server to charge you hourly rate to build the artifact. And code build handle all the workload, build things in parallel. This is the first thing. And then second thing is, suppose you really want to use Jenkins build server. You can have the Jenkins plugin to integrate with EC2 auto scaling, so that if you need more resources, they can AWS can spin up more EC2, more Jenkins server to help you build a job. And another thing is you can use Jenkins to do the orchestration, just like the code pipeline I did in my demo. All right, just like another cloud platform called GitLab. All right, many people, they come from the on-prem environment. They are already using Jenkins to do the orchestration. You can still do that, and the Jenkins can also as a stage in code pipeline to help you build the artifact, test it, and there is a lot more plugin so that you can integrate with, say, for example, SNS, DynamoDB, and much more. All right. So these are some example by integrating Jenkins with our AWS DevOps environment. Okay, thank you.
Thank you, Brian. And once again, I want to remind you all that as you do leave the session today, you'll be presented with a short survey. We would like you to help us by taking a quick moment to participate in that short survey. Your feedback really helps us understand your learning experience as we are constantly looking at how we can improve our future sessions with all of you. The survey answers are measured on a scale of 1 to 5, 1 with 5 representing outstanding and 1 representing poor. And we want to thank all of you for joining us today. And if you do come up with any additional questions, feel free to send them to webinar@netcomlearning.com at any time. We hope that you found today's webinar informative, and we look forward to seeing you back here with us soon. Feel free to tell your friends and colleagues about our webinars and other courses. Have a great day, everyone.